Chairman of the session is Dr. A.V. Raghavan, Sir, Professor retired IIT Madras. I request to Dr. Raghavan, Sir, to chair the session. Co-chairman of the session, Sri D.R. Megwal, Sir, Additional Secretary, PWD, Rajasthan. I request to Sri Dr. Megwal, Sir, to co-chair this session. May I request to Sri Navneet Chaudhary, Sir, Under Secretary, R&B, Gujarat, greet by bouquet to Chairman of the session. May I request to Sri Sami Mistry, Sir, Under Secretary, R&B, Gujarat, to greet by bouquet to co-chairman of the session. Thank you, sir. Now I request to all presenters to come on the stage. Dr. Yogesh Kumar, IIT Roorkee, Professor Praveen Kumar, Sir, IIT Roorkee, Dr. Samesh Ravindranath, Sir, IIT Roorkee, Sri Ankush Kumar, Sir, Research Scholar, Sri S.K. Nirmal, Sir, Secretary General, IRC. Sri Sudesan K.P. Popli, Product Manager, NHAI. Now I request to Chairman of the session for opening remarks.
Thank you. A very good morning to all of you. I think because there are parallel sessions, the audience number is very less. Nevertheless, interested people are here. So we have three interesting presentations today morning. The first paper is paper number 719 on the effect of molecular structure of SBS polymer on conventional and rheological properties of modified asphalt binder, linear versus branched SBS polymer. In fact, IRC released the latest code IRC SP53 only 2 days back. Yesterday in the inaugural session, it was approved in the council meeting 2 days back. We will be coming out with a new code of specifications on the polymer modified binder. It's time that we also discuss about the effect of molecular structure of the SBS polymer on the rheological properties. It's eminently prepared by Professor Praveen Kumar, Yogesh Kumar, and Sri Shyam Ravindranath. So let me now request Professor Praveen Kumar to present the paper.
Chairman, sir, Professor Veera Raghavan, Secretary General of IRC, Shri Nirmal Sahab, Megwal Sahab, Co-Chairman, and my co-authors, co-presenters in this session. It's a session having more presenters than the audience. So I believe that the presenters will hear each other and will try to convince them. This paper is being presented by me. I'm from the area of pavement and roads. We have Professor Shyam Ravindranathan, who is a polymer expert. And we have our PhD friend, Dr. Yogesh Kumar, who is working in industry. We we are working for the last more than 2 decades. We are working in the area of polymer modification of the bitumen. And we have various products in the market like PMB40 and all these things. And what they are adding, whether they are adding SBS, EVA, or sometimes sulfur also, it is their trade secret. It is not discussed in IRC or any other session what actually we have in these. So this part is left to the academicians and researchers to do something in the lab and decide what is the percentage of these materials, what are the different type of modifiers. And we, as I said, we have been presenting the papers, guiding the PhDs for last more than 2 decades. But before that, why we do the modification? This is also important, why we do the modification. And before that, another question is, why we use the bitumen only in the road construction? Because we want a material which should be liquid when we are mixing it with the aggregate. It should be semi-solid when we are compacting it. And it should be solid when it is working as a road. And only bitumen has these all 3 qualities. At different temperatures, it works as liquid, semi-solid, and the solid. This quality becomes negative when it is excessive. It is true for a human being also. If you have anything excessive, it becomes your negative point. So for the bitumen also, when these quality, that is the temperature susceptibility, is excessive, then it becomes the problem, it becomes the negative point with the bitumen. So to reduce the temperature susceptibility, we go for modification of the bitumen by the polymers. So we will summarize these things in this. We all 3 will be sharing some slides so that I will be covering the general part. And then Dr. Yogesh will come, and then finally Dr. Sham, who is the polymer expert, he will be coming. And you can see here that the polymer is coming from poly plus mers. Poly means from Greek, these words have been taken. Poly means many and mers means units. So when a single unit is there, it is monomer, and when it is polymerized with the covalent bonds, it is polymer. But the polymers are not only these SBS, EVA, etc. Polymers are available in the system in the natural form also. For example, we have the cellulose, which is having the source the wood or cotton, and its application is the paper industry, paper clothing industry. We have starch, that is the potatoes, corn, etc. are the source. Then we have the wool, which is coming from sheep. We have the silk, which is coming from silkworm. We have natural rubber that is coming from rubber tree. We have the other things which are coming from oil deposits. So these are, of course, not being used as such much. But you can see in the DNA also, these are the polymers. So polymers are everywhere, natural and synthetic. And this is the formula for styrene, butadiene styrene. As you know, mainly in the country or in the world, among the polymers, we are using SBS, EVA. These are the main 2 polymers which we are using. You can see this is the structure of styrene, butadiene styrene. It is consisting of styrene as well as butadiene. You can see here, this is a thermoplastic elastomer, and it is a block copolymer. It is linear and radial structures, and SBS captures 80% of the global PMB market share. Of course, these all things which till now I have discussed are not new. All of you know, because all the persons who are sitting in this session, they are experts from this area. But what we are trying to tell in this session is that telling that it is SBS, it is not enough. SBS may again be of different type. Depending upon the structure, it may be linear, it may be high vinyl, it may be branched. So there are 4 types of SBS which we have tried to discuss in this PhD work, which was done by Dr. Yogesh and under the guidance of Dr. Sham and myself. So we tried to find out among these 4 types of SBS, which is better, what are the properties, how these are varying when we are using these 4 things. So I will request the second author, Dr. Yogesh, to come, and then finally Dr. Shyam.
Thank you, sir. Good morning, all. So, this next section, I will be covering about SBS concentration, and which will be seen from this data. So, the first graph which is presenting is load carrying capacity, and with respect to SBS concentration. So, before moving into SBS molecular structure, the most critical part for the bitumen modification is the polymer concentration. So, in this case, the load carrying capacity is presented with respect to SBS concentration. As we can see from this graph, that when we increase the SBS concentration to the bitumen, so the load carrying capacity start to increase, and then further, if you increase the concentration to 3% to between 3% and 6%, the softening point increases considerably, which is reflected, which can be observed from the morphological images, which is SEM, scanning electron microscopy, and fluorescence microscopy. So we can see from the first image, like at 3%, the SBS is having a very poor nitric structure with bitumen. So that's why it is unable to carry a much load. When we increase the SBS concentration to bitumen, there is a strong density of nitric formation with bitumen, and it become a meshy structure, 3-dimensional nitric structure, which can carry a more load. Further, when you increase the SBS concentration to 7%, so there will be strong interconnected nitric structure, and we have a higher load carrying capacity at higher concentration. So these images is obtained from SEM and fluorescence microscopy. So the fluorescence microscopy shows that the lighter phase, which is green phase, which is due to a polymer, and the darker phase, which is due to a bitumen. So when you increase the SBS concentration, the lighter phase density of lighter phase increases, which indicate the strong nitric formation in the PMB. So the conclusion of this presentation slide is the SBS interconnected network result in a steep rise in the property above 3%, and the most critical zone is 4 to 5-8% in the bitumen. So after SBS concentration, I have tried with different type of bitumen obtained from different sources. So when you modify bitumen with obtained from different sources, we don't see any significant difference among different bitumen type, majorly because it interact in a different with respect to concentration effect is more dominating compared to bitumen type. So this can be observed from the phase angle also. Phase angle is the data which is obtained from the rheological analysis of PMB. So we can see from the graph that when the percentage of SBS is increases in the bitumen, so phase angle decreases considerably. Higher phase angle indicate the lower elasticity, and when we keep on adding the polymer to bitumen, the elasticity increases considerably, which is reflected from the lower value of phase angle. So this SBS concentration elasticity is reflected from when we do the study on the asphalt mixes, study on the mixes. So the first study, which is for the rut depth with respect to a different polymer content. So we can see from this graph that when the percentage of SBS in the bitumen is very low, around 3%, so the rut depth is very high. And when you go for a higher concentration like 4% and 4.5 to 7%, the rut depth decreases from 8 mm to almost 4 to 3 mm. So there is a huge, enormous decrease in the rough depth because of the role of SPS concentration. The second study, which is fatigue life with respect to polymer content. So 4-point bending beam testing was carried out, and we can see from this that almost 5 times decrease in the fatigue life is observed when you go for a polymer concentration of 4.5 to 7%. So this SPS concentration is reflected from is indicate to our PMB grade, which for different load like extreme six. So for 4 to 4.5% is the ideal grade, ideal weight percentage range for different PMB grade. So this range having effective, highly effective for different grades and very narrow differences SBS concentration. So now next is after concentration, the next important effect of SBS structure on the performance property of PMB. So there are 4 basic type of SBS polymers, which is linear structure, branch structure, and the die block. So in linear structure, there are 2 grades, D1101 and D1192. These 2 are linear grade. Branch is 1184 and the die block is 0243. Die block is having only 2 styrene and butadiene, and others are having styrene and butadiene and styrene again. So different companies are selling different type of SBS, but majority of them are having a ratio of 30 to 70 styrene and butadiene. So this is the chemical structure of linear high vinyl, high die block and the radial. So right side is the radial structure. So we can see from this chemical structure that when you having a double bond in the main chain, which is in the middle portion of butadiene, so it is for linear, and then when the double bond shifted to a side chain, it become a high vinyl structure. And further, when you go to die block, it is having styrene and butadiene, but again it is having a double bond in the side chain. So when you shift double bond in the side chain, it is very effective in for the thermal stability for PMB, which we will be discussing in the later slide. So the performance property of different type of chemical structure with respect to bitumen was carried out, and the load carrying capacity again obtained from softening point was plotted with respect to SBS content. So we can see from this graph that among 4 SBS polymers, branch polymer is having a higher load carrying capacity compared to linear and other polymers. And the difference between the softening point value is around 20 to 30 degrees Celsius, which is considerably huge when you modify and when you actually make the analysis for load carrying capacity. So the right curve, it is indicating the elastic recovery for different type of molecular structure. So elastic recovery analysis was carried out using dynamic shear rheometer. The temperature for that is 60 degrees Celsius, and we can see that when the SPS concentration is around 4 to 5%, the elastic recovery is around above 95%. And for high network like branch structure, it is having a elastic recovery higher compared to a linear and die block, because for lesser concentration you will get higher elastic recovery compared to other 3 polymers. So branch is having a highest property compared to other 3 polymers. Linear and high vinyl are giving us almost similar property, whereas die block is having a lowest performance property in terms of load carrying and elastic recovery. So the study on the asphalt mixes was carried out using these four SBS polymers, and the first one is the wheel tracking, which give you the data for dirt depth. So when you when we modify our bitumen using 4 SBS polymers, so among 4 SBS polymers, the branch is having a lowest rut depth value compared to the other 3 polymers. So the polymer content kept for that is 4.5, and the same analysis or the reflection of rut depth can be observed from the stiffness data. So stiffness data indicate that when the concentration is around 4.5, the branch polymer is having higher stiffness. So higher stiffness is better for rut depth. The second study was carried out using a fatigue analysis. So fatigue also among 4 SBS polymers, this branch is having a higher, better fatigue life cycle compared to the other polymers. And indirect tensile stress also indicate the same phenomena among 4 SPS polymer. Branch is the better polymer among 4. Okay. So asphalt performance is having a performance of like branch. When you modify, it is having 20% higher performance property. Linear and vinyl are almost similar property, and die block is having a lowest property. So this next section, which is thermal stability, which will be covered by the Dr. Shyam sir. Thank you.
So the point here is the radial or the branch polymer gives the highest performance in terms of binder properties and in terms of mixture performance. Then what is the point of using high vinyl content? So all of us are aware that the bitumen during manufacturing, during storage, during construction, during use in road is subject to high temperature, high moisture content. So the aging of the PMB becomes the most critical parameter. Initially it can have good properties, but what will happen after during use of 1 year, 2 years? So here the data clearly says that the linear and the radial, which is the black and the red data, clearly shows that during usage or during storage, its properties gradually erodes. But the same erosion in the properties is not observed as in the case of a high vinyl content SBS polymers. So what is the trick? The trick is the moment you increase the vinyl content, the double bond which is in the butadiene goes to the side group. So this double bond is highly susceptible for chemical reactions. And even if this double bond reacts, the main chain of the polymer remains intact, because of which the properties of the PMB and the properties of the mixture remains intact the moment we use high vinyl content polymers. So as a summary, I would say that 80% of the PMBs globally is produced using SBS modified bitumen. SBS is a thermoplastic elastomer, which is very, very important to understand. So it has a thermoplastic which gives stiffness and elastomeric component which gives elastic properties. So both rutting, Marshall stability and fatigue life is greatly enhanced. And in case of PMB, in all case of PMB, the concentration of the polymer plays the most pivotal role. And the moment there is a network that is created by the polymer, the properties greatly enhance. So the first important point to understand is a network has to be created within the bitumen. And that can be formed in SBS only above a weight percent of 3 weight percent. And I would suggest at least use a PMB of SBS PMB with 4.5 to 5 weight percent of the polymer in the bitumen. This is the most critical component. The moment you say, sir, we are using SBS modified bitumen, properties are not coming in the mixture, it won't come as long as you go to a concentration of 4.5 to 5%. This is the most critical component. And structure in India, you get linear, radial and high vinyl. As I said, the radial polymer gives the highest mixture performance, highest properties, but it has a disadvantage that the moment you go above 4% of radial, it starts gelling. It's not very stable. So commercially, there is it's difficult to use. So my suggestion is, if we have to always go to PMB 82E, irrespective of what type of road, we have to go to PMB 82E, because only in PMB 82E we get a concentration of the polymer above 4.5%. Okay, at least in wearing course it has to be there. And in terms of different polymers, I would recommend high vinyl, because not only it gives initial performance properties, but also during aging it retains the properties that is expected from it. So high vinyl SBS is the better grade. And many of the European countries, they even in DBM layer, they use PMB. So I think that we have to promote. That is my recommendation. Yeah, cost is very high initially, but overall longer performance has to be considered. And in terms of sustainability, I know there is a lot of talk about sustainability, but the best sustainability is, can we ensure the performance of road over a period of 10 years, over a period of 20 years, so that there is no relaying, there is no minimum maintenance issues. So that is the best sustainability factor. And PMB is now ideal not only for highways and expressway, it also has to be considered for rural roads and roads where there are marginalized aggregates. So I would stop here. Okay, thanks.
Thank you. I think we'll take up the discussions at the end, because once we start the discussions, then time for the available for the next session will be lesser. So we'll take up the next paper, paper number 718 on the composite bitumen modification using waste plastic pyrolysis oil and scrape non-tire automotive rubber for sustainable payments. The authors are Ankush Kumar, Professor Rajan Chaudhary, and Mr. Sanjay Nirmal. I think, in fact, Sanjay was the first presenter of a paper on a polymer modified bitumen way back 2 decades back. That enabled us to issue the first IRC code on modified binders. It has been implemented for decades now. I think let us hear from Mr. Sanjay what are the modification that they propose, which will enable us to have better performing modified binders in the country. Over to Mr. Sanjay.
Good morning, Professor V. Raghavan, Chairman of the session, Co-Chair Mr. Megwal Sahab, then my co-authors, the authors on the dais, ladies and gentlemen. As already introduced by Professor V. Raghavan, that I am in the business of modified bitumen for last 26 years. In fact, I did my post-graduation from Delft University, Netherlands, and there the topic of my study was modification, polymer modification in the bitumen, and how it is compared with the VG grade bitumen. And based on the data collected in India, I did this study in Netherlands. And I came out with a paper with Professor Molenaar, who was my supervisor that time. And that was the first paper in IRC session on this subject. And I presented that paper in Hyderabad session. Though Professor Molenaar could not come, but I presented this paper. And there was so much of enthusiasm, even at the political level, because during the inaugural session, even Chief Minister of Hyderabad, he also said that, yes, looking at the properties and the benefits, I will be the first state to introduce this technology, I mean modified bitumen in my city roads in Hyderabad. And then in IRC also we took up this subject, and we came out with the first code on the modified bitumen in 1999. And then we had to revise it based on the immediate feedback in 2001. And there was the second revision in 2010. And just 2 days back, in the council meeting, we have come out with the third revision, which has been approved by the council. So this is the growth of modified bitumen. Now, this is one aspect that, yes, we know that the modified bitumen is certainly better, because the condition of India, I mean, we have a temperature variations, huge temperature variations, we have overloading, traffic loading. So definitely there is a need for modification in the bitumen. Then apart from that, there are other aspects also, that we have a huge road development program. And the government of India this is the highest priority. Even in the current budget, the highest allocation has been given to road sector. Our ministry, 2.7 lakh crore. That is more than 35% increase in the previous year's budgets. So that is the kind of budget we are getting for the road transport ministry alone, which is dealing just with national highways and expressways. Similarly, PMGSY and the other schemes are there. So there is a huge demand of bitumen. Now, there is we also know that there is a large gap between what is bitumen we are requiring and what is available in our Indian refineries. In fact, in last 6 months, I had 3 meetings, 2 at the level of minister and 1 at the level of secretary, where we invited all the manufacturers and discussed this issue, that how to improve the quality of bitumen. And in those meetings, our minister was very clear that we should have less import and try to develop the indigenous products under Atmanirbhar Bharat. So let us try to be sustainable in this area also. We all know that PMB is better. There is no dispute about that, that SBS is better than the rubber modified bitumen. That we know right from the beginning. So our, now the, Ministry of Road Transport as well as our own, we are also thinking that we should develop the indigenous technology rather than importing polymers and all that. Though my first topic was polymer, but now I want that even in the, when I was in Czech Republic, there we were discussing on sustainability. Our minister told me that we have to promote rubber and plastic. So how to promote that? We have to see that the indigenous research we should promote. So this issue I discussed 2 years back with my friend and my junior in the college, Professor. He was Rajan. He is a IIT Guwahati professor. So then that time we came across that yes, this is a very good area and they are doing some work, and I associated with this particular topic. So in this particular research, this is a composite modification. I mean, we are using both plastic as well as rubber. So the plastic, we know that waste plastic, IRC came out with the code in 2013. That was the first code, and I think internationally there was no other code by any other country at that time. And when I was presenting this topic, sustainability in Abu Dhabi, then they said that Western countries were scary about this, that how you can use waste plastic in roads. Then I told that already 10,000 kilometers of roads of PMGSY, we have already done it. So then they said, we want to see the experience in India, and based on that, we will come out with, in US and Australia and UK, we will come out. Otherwise, UK, particularly TRL, was very opposing this waste plastic. Even in the ministry's study, they said waste plastic may not be durable. But they wanted to, then they agreed, yes, we will see the feedback in India, and we will also come out with the codes. And I'm happy that Australia has already come out with the code on waste plastic, and US, UK, they are also working on these lines. So our target is that how we can utilize this waste plastic, how we can utilize this rubber, and make our bitumen, substitute this in bitumen and make this modified bitumen better than this just waste plastic modification, just rubber modification. So in this particular paper and study, we have seen that the properties can be further improved. If you see standalone waste plastic modification or standalone rubber modification, if you do this composite modification, we don't use, in this particular study, we have not used the crumb rubber which is prepared from tire. It is non-tire crumb rubber. So there are other waste rubbers available from even automobile itself. Similarly, for plastic is another form, on the form of oil. So when we combine these two in the bitumen, we find that the property is much superior to the other earlier bitumens. So this has been established through the various tests which is required, and is much more stable than the crumb rubber modification. So the technical aspect, now I will invite my other co-author, Ankush, to take the further presentation. Thank you.
Thank you, sir. Good morning to all. So I will continue the presentation. So moving forward, so as sir has discussed that there is a need for sustainable materials as asphalt binder modifiers, which are able to give improvement over a wide range of properties such as adequate viscosity for the construction phase, improved rutting performance at high temperature, better fatigue cracking at intermediate temperature, and improved low temperature cracking at sub-zero temperatures. Therefore, for that, we can attempt the composite modification by employing waste-derived materials, where the composite modification is defined as the use of a combination of different modifiers for asphalt binder modification to mitigate the limitations in asphalt binder characteristics with the use of a single modifier. In this study, we have used waste non-tire automotive rubber and plastic pyrolytic oil that we will discuss in detail in the coming slides. As we know that there are so many rubber components in a normal vehicle, and in those rubber products, uh, tire rubber is about 70%, while other 30% by rubber weight is other non-tire automotive rubber components, basically in the form of weather strips, hoses, vibration insulators, etc. And in those non-tire automotive rubber components, EPDM shares about 50%. So EPDM is defined as a tough polymer of ethylene, propylene, and a diene monomer component, and it also finds its application as roofing materials also. So we inquired about the fate of these non-tire rubber components in Assam and in Bihar, and at many automobile service stations, and we found that these non-tire automotive rubber after their life are just dumped as waste, as municipal waste. So we tried to explore alternative source of its application as asphalt binder modifier. So coming to the second component of the modifier, that is a plastic pyrolysis oil. So as we all know that the plastic waste has been a menace for India and globally. So pyrolysis has gained significant interest as a sustainable and reliable technique for management and energy valorization of plastic waste. So in this pyrolysis process, what we do, that we collect the plastic waste, we clean it, and then we shred it in smaller sizes and feed in a pyrolysis reactor for thermomechanical and chemical decomposition at very high temperature to generate vapors. Those vapors are condensed to obtain the pyrolysis oil, while the uncondensed pyrolysis gas or vapor are used to run the pyrolysis reactor, and also the solid carbonaceous plastic pyrolysis char are generated. So coming to the materials used for the modification in this study, a viscosity grade 30 base binder was used, and the EPDM rubber granules or powder less than in size 300 microns was used at a dose of 16%, and the plastic pyrolysis oil was used at 6% doses. These doses were selected based on our past research studies. And moving forward, for binder modification, two different modification approaches were used. First one was the individual modification, where respective doses of individual modifiers were used. And in composite modification, three different methods were used, where sequential addition, heat pretreatment, and microwave pretreatment were used, which we will discuss in detail in the coming slides. And the prepared binders were evaluated in terms of separation test, viscosity at 150 degrees Celsius, and rating characterization in terms of superpave rating parameter and MSCR test, fatigue characterization in terms of superpave fatigue parameter and LAS, and the low temperature characterization in terms of frost breaking point. So for binder modification, for individual modification with PPO, the respective dose of PPO was added to the base asphalt heated at 120 degrees Celsius and high seared, and the prepared binder was termed as PPO. While for the individual modification with EPDM rubber, the rubber granules were added to heated asphalt at 160 degrees Celsius with a sear mixing using running at 5000 RPM for 1 hour, and the prepared mixture was thermal conditioned for 2 hours at 160 degrees Celsius. For composite modification using sequential addition, first of all, the PPO was added to the heated asphalt and then sear mixed. Thereafter, the PPO added asphalt was mixed with, the EPDM rubber was mixed in the PPO added asphalt, and that combination was high sear mixed at 160 degrees Celsius for 1 hour. And thereafter, the whole mixture was thermal conditioned for 2 hours. In pre-treatment approaches, for both microwave and heat pre-treatment, PPO was priorly added to the EPDM rubber, and that mixture was stirred using a stirrer. Thereafter, that composite EPDM and PPO composite were microwave pre-treated for 2 minutes in a microwave oven in the case of microwave pre-treatment, and the EPDM and PPO composite was heat pre-treated for 2 hours at 90 degrees Celsius in an oven. Thereafter, the binder preparation approach was same, where the composite was added to the base asphalt and high sear mixed. Thereafter, the mixture was thermal conditioned. So coming to the first test, that is separation test, which is used to evaluate the compatibility of modifier with the base binder. The test was conducted in accordance with ASTM codal provisions. As we can see here that the RMB binder, that is the binder having individual modification with EPDM rubber, surpasses the maximum threshold of 4 degrees Celsius that is specified in Indian codal provisions to have a binder having a adequate storage stability. So the RMB binder was not storage stable, while the PPO added binder was completely storage stable. Again, for the composite rubber modification with sequential addition, we can see here that the SPD, that is softening point difference, decreases, but it was still surpassing the maximum threshold. While for composite modification through pretreatment approaches, the softening point difference was was reduced significantly, and this significant improvement in thermal storage stability can be attributed to the pre-swelling of rubber granules with addition of PPO subjected to heat and microwave pre-treatment. As we can see in the adjacent same images, that untreated rubber particles are having a flatter and rough but flatter morphology, whereas the pre-treated rubber are having a swollen morphology. So this swollen morphology of pre-swelled rubber helps in the dispersion, breakdown of these rubber particles and homogeneous dispersion in asphalt matrix during rubberized asphalt production. And this can be confirmed through the AFM micrographs in the adjacent figure for the top and bottom tube subsections, that the micrograph of RMB binder are having dissimilarities, while the micrograph for composite rubberized binder with heat pretreatment are more or less similar in microstructure. Coming to the viscosity, which is a fundamental characteristic of a binder and is important to assess for their as they are important for pumpability and workability of asphalt binder and mixes during production and construction phases. As we can see here that with addition of EPDM rubber alone, there was a significant increase in viscosity with around 200%, and the viscosity decreased by 40 to 50% in the case of individual addition of PPO. While for composite modified binders, the viscosity was higher than base binder, but lower than the RMB binder. And all the rubberized binders made the requirement of kinematic viscosity between 4 to 12 poises or 0.4 to 1.2 Pascal second for different grade of rubber modified binders in the Indian codal specifications. Coming to the rutting performance at high temperature, the test was conducted with dynamic shear rheometer with 25 mm diametrical DSR plates, and the binders were tested after short-term aging. And the test was conducted at 64 degrees Celsius for both super rutting parameter and MSCR parameters. And as we can see here, in both rutting parameter and MSCR GNR, that the rutting performance of RMB, that is EPDM rubber modified binder, is significantly improved, and the rutting parameter of composite rubberized binder with heat pretreatment and microwave pretreatment were comparable with the RMB binder. While in MSCR recovery, the recovery for composite rubberized binders were significantly higher, and the recovery of the composite rubberized binder after heat pretreatment were about 250% higher than the base asphalt binder. So this indicates that the pre-swelling of rubber with PPO under pretreatment, these pre-swelled rubbers acts like as a flexible particulates in the asphalt matrix, and those particulates are able to deform under loading, and they are able to reform very well after when the loading is removed. So in terms of fatigue performance, the fatigue parameter and LAS fatigue life was conducted, and as we can see here also, the composite rubberized binder with heat pretreatment, the fatigue parameter were increased significantly by around 250%. And coming to the thermal cracking, the frost breaking point was conducted, and as you can see here that the PPO is having the highest frost breaking point because of the softening effect it imparts to the base binder, while the composite rubberized binders were also having a frost breaking point comparable to the PPO. So coming to the benefit analysis, majorly four parameters were important for different modified binders. That is storage stability, rutting, fatigue cracking, and thermal cracking. So the PPO binder was storage stable while it was having a detrimental effect on the rutting parameter and having a moderate improvement in fatigue and significant improvement in cracking. The binder modified with individual modification with EPDM rubber, the binder was not storage stable, while this improvement was significant in rutting and fatigue and moderate improvement was in cracking. In composite modification with sequential addition, the binder was not storage stable and the improvement in rutting was very moderate and significant improvement was there in fatigue and thermal cracking. While in composite modification after pre-treatment through both heat and microwave pre-treatment approaches, all those four parameters were improved. So the most synergistic improvement was observed in this composite modification with heat and microwave pre-treatment. Coming to the concluding remarks, the aim of the study was to examine the properties of bituminous binder developed from waste EPDM rubber and plastic pyrolysis oil in individual and composite modifications. And as we discussed earlier, that the storage stability for the EPDM rubber alone was not storage stable, while the composite modification with EPDM rubber and PPO after pre-treatment significantly improved the storage stability. Similarly, the rutting and fatigue performances were also improved, and the low temperature performance was also improved, and that can be attributed to the pre-swelling of the rubber particles by PPO, which is accountable for the enhanced low temperature performance of composite modified binders. So the recommendation, the most synergistic improvement was for the wider temperature domain and the different asphalt binder properties was achieved by the composite modification with EPDM rubber and PPO through pre-treatment with heat and microwave irradiation. This composite modification with waste-derived EPDM rubber and plastic pyrolysis oil can be a crucial step towards attaining sustainability. We would like to extend our sincere acknowledgements to Tikitar and Sail India Private Limited for providing BG30 binder, GoNV Technologies Private Limited for supplying the plastic pyrolysis oil used in this study, and also we would like to thank Indian Oil R&D Center Faridabad to allow and support for the low temperature test characterization of bituminous specimens. Thank you for your patient listening.
Thank you, Sanjay, for this wonderful presentation. We have the last presentation, NHAI One App, revolutionizing road safety audits to enhance traffic safety by Mr. Sudarshan Popli, Rahul Gupta, and Mridula Raghavan. May I now request Mr. Sudarshan Popli to present the paper in 15 minutes.
Thank you, Professor. Co-chair, authors present on the dais, ladies and gentlemen. As everybody knows where we stand as far as the safety is concerned. We have a very good network of roads, but yes, we are number one also as far as road-related accident deaths are. So last year in NHAI we have did the road safety audit for 20,000 kilometers. So having a network of 80,000 kilometers under the jurisdiction of NHAI, a need was felt how to further fasten it and strengthen the road safety audit so that the accidents on the highways, particularly under the jurisdiction of NHAI, can be reduced. So that's how that time CGM, Mr. Lochan, and GM, Mr. Bansal, has initiated this thought process. And finally, when I joined NHAI after retiring from rides, I had 35 years of working with rides and 20 years of road safety audit. So I further progressed this, and finally the mobile app has taken the shape. It's difficult to make a presentation like this, but I'll try my best to present this mobile app. So this is the flow basically. What's a safety audit? In 2019, I was also committee member for this and drafted the checklist for this manual on road safety audit 2019. It's a formal systematic and detailed examination of a road project by an independent, I stress on this, it's an independent and qualified team of auditors that leads to a report of the potential safety concern, what are existing or potentials in the project. So there were two approaches. One is reactive and other is proactive. So safety audit is a proactive approach. So these are the various stages of the audit for different category of roads. In expressway and national highways, in NHI now we are doing for all those stages right from the planning, DPR, construction, pre-opening, existing, and for all modes of the projects which are being awarded on BOT, hybrid, EPC, item rate, and whatsoever you call it. So how this flow has started, first of all, a road safety policy has been declared in 2022. 94 teams have been impaneled. Projects have been identified. A safety audit team has been appointed. Earlier, it was a tender process, and very shortly, we are going to start on fixed cost roster basis. Already the cost has been declared, and it will start any moment now. Hand over the relevant drawings and design reports to auditor. Commencement meeting is very, very important, so that all the stakeholders are on the same footing. And then a desktop audit of the drawings and designer reports. Detailed inspection of the site, it's required day and night. Identify the safety issue, conduct completion meeting, because the committee, Road Safety Committee of Supreme Court, they ask for it. They want to ascertain whether the safety audit team is visiting at site or they are simply submitting the report sitting in the office. So they have asked for completion meeting. So it's an important part and issue of the minutes of the meeting. Preparation of the audit report, it should be signed by the team leader, road safety auditor team leader. Then it is to be accepted or rejected, some of the observation by the basically project director or NHEI, and then forward that road safety audit report to IAE concessionaire contractor for implementation. This was the process, or this is the process which is being generally followed for the safety audit till we have gone for the road safety audit mobile app. So this is basically DPR stage where we have now included, yesterday in the panel discussion it was told that it is DPR is not being prepared. So it is being audited now on all those stages. And lastly, from where the contractor start works, they work on to the schedules. So then auditor has to even audit the technical schedules, that whatever audit recommendation he has given during previous stages, that has been incorporated not. Even in October, NHA has issued standardized sample schedules of B and C, where the complaint of that there are ambiguities that will also be addressed. Although I am getting the complaints now that NHA is going on item rate basis. On the otherwise, they say you are not giving details when I have prepared it, a detailed schedule B and C. Now there is a complaint for other side also. And DPR consultant has to give certificate of compliance. So then it's a construction stage, pre-opening stage and operation stage. Everywhere it has been made mandatory that now the accident analysis should be carried out. So these are the specifically checklists, that is IRC, SP88, it is there. And this is the format of the reporting which is in SP88. So now I come to road safety audit mobile app on NHI One app. NHI One app is a global app where it is particularly for the consultants, concessionaire contractors to report and resolve road related issues. It has been launched only last year, September 2022. Available on Android and iOS. Modules on NHI One apps are 5 modules, and lastly was added this road safety audit modules. This is basically overview of the safety mobile app. It is developed in-house, no support. It was not being any outsider has worked on to this. It's a NHI IT team who has worked on to this with the road safety division, where I have extensively supported that. Safety auditor conducts site safety audit and observation gets uploaded in data lake. No audit observation can be deleted. This is very, very important, that once it has been, means you have clicked the photo, it will remain there. Then it is to be reviewed by PD and RO, and then it is to be implemented and confirmed by authority engineer or I, that yes, it has been implemented. And as far as while sitting in headquarter road safety division, I can glance in one go that where the status is, where the road safety audit observations are pending or it is being complied. So this is the workflow. Anything, unique user ID is being given and password for safety auditor. It's then he did that, record the audit observation while visiting the site, approves or reject PD regarding the observations, and then accept reject recommendation by RO. Further it comes back to PD and then it goes to authority engineer I. They start, give the order for implementation, and then finally it is being, the feedback that it has been, the inspection has been done and it has been implemented, then accept and reject, and finally an RO accept this. So the process which I explained earlier, we try to match in the NHI 1 app, and further additions have been done. This is how the process in mobile app is there. It's basically how the safety audit module is there. So many, it has been conducted, road safety audit, and this is basically a package ID is being created, and then project code, what is the, who is the consultant, and what is the stage of the audit, and different stages of the audit. This basically, when he goes to the site, then he basically changes wise the observation, what is the safety issue. Safety issue means it's the main checklist, then it is subcategory, and then it is the basically observation can be edited, and final recommendations like that. It's like that complete, it comes the main category, then it comes the subcategory, and then it comes the basically what is the observations and recommendations. He can just type a very brief, and later only these two columns can be, two rows can be edited. No other thing can be edited in the mobile app. So what's basically helpful features are, it's a geotagged inspection you cannot do. You have to be at site. You have to do every day in the morning before starting the audit, that your selfie is to be uploaded, that you are onto the site and started the survey. And then it will be also geotagged that you are already on the project site, not sitting in the office. And all the safety audit inspection will be geotagged. Then prioritize the fields based on their risk and severity. Editable fields, only these two, where he wants to change the language, he wants to have the observation and other things, he wants to have some corrections or editing he has to do. After this launch of this app, we got this, that certain number of observations are repetitive, so they have to again do it again and again. So then duplicate observations means, it's say this payment marking is it's not visible, so he can repeat that, or safety barrier is damaged, he can repeat that. So that's how it is, this has been created. Then this is successful launch of how it has started. First of all this checklist has been formulated. So as I told you, in basically SP88, the three checklists are separate: planning and feasibility and DPR. So it is required for an auditor to have all those checklists if he is starting from the DPR. But in this case, I have clubbed all those three checklists, and accordingly one checklist has been given for the DPR, one for construction, one pre-opening, and one for operation and maintenance stage. Mobile app, it has been developed by IT team. On the site app, I went to the site, I did the trial, and then whatever observations are there, those bugs have been removed. Then on-site trial, I offered to two auditors, they did it and given the feedback. Then a workshop and hands-on training has been conducted in NHI headquarters. And finally, it has been launched in April 23, only 8-9 months back. And then as on date, 24/7 support to the auditors as far as app is concerned. Anything comes up, it's a mobile, this WhatsApp group has been created where they raise the issue, they raise the ticket, and then that ticket is being resolved on the WhatsApp itself. So that support is available from the NHE IT team and road safety division. That is basically that how this mobile app has become very popular, and now it is being used very effectively. So this is a workshop which has been conducted before the launch. It's a hands-on training has been given. All the individual auditors have been taken to the field, nearby roads only, and then they have been trained that how they have to do the audit. That's how it has been done. And this is the successfully then it has been done. So many audits have been conducted in all stages, pre-opening, construction stage, operation maintenance stage, and we have not stopped there. We have further gone ahead. We have having the feedback from the auditors regularly, and then number of modifications have been done. For example, duplicate entries, it has been now introduced. Video clips, they want to add some videos wherever they want to impress upon. Those now has been added, they can upload the video. After that, photo attendance during the audit, and option meeting, minutes of meeting. Basically that, as I told Supreme Court Committee on Road Safety, they were insisting on minutes of meeting. And reports, sometimes I have gone through the report, some reports are 400 pages. How do one go through it? So it has been made mandatory. They have to upload the summary of the audit report so that it can be easily understood while we are doing the monitoring at the headquarters. What are the new and upcoming fields in the mobile features? Offline mode, because so many places it's internet may not be available, so they requested for this, that offline mode, they can continue with that audit. Now they are on the site and internet is not working, or there is some problem in the server at the NHA headquarters. That's how it is being now, offline mode has been created, because internet is required that whenever they do the click the photo, and then they give the observation and they say submit. Once they submit that particular observation, that immediately uploaded into the data lake of NHI module at headquarters. So it's immediate, you cannot then take it back, and you cannot delete any observations. So if there is some problem in server, to address that, this offline mode, it has already been developed, it is under trial, and it will be, again, by new year, it will be available to the auditors. Then automatic conversion of mile-based observations into the report form, because they were saying they are having duplicacy of work. Once they have to do, because earlier if the audit is being done 2 to 3 days for 100 kilometer, now they are taking 5-6 days. But then again report has to be prepared, that means another 1 week, so that will be shortened. Whatever report I have shown you, that the observation they are going on, and the report in IRC SP88, as I have shown, that kind of report will be in the Word-based document will be available. They have to just take out a printout and submit it. Then dashboard, so everything has been done, audit has been done. Now how to monitor it? PD is occupied, so many works, and the RO is occupied. So I is occupied, the third, everybody is occupied. Then only we are constructing so much huge road network. So even the headquarters also it is occupied. So this dashboard on the phone will be available. So whenever he clicks, he will get the feedback. Even anybody can get the feedback. Chairman can have the feedback that how many audits have been conducted. As if I give you today, till September 30, NHA has conducted 20,000 kilometers of safety audit, which was a yearly basis only. Till 2022. So that's how this will be available, and from the click of button we will know where it is pending, who is the PD, who is the I, so he can be accordingly called and stressed upon to take care of that. Then another feature we are going to add, it is lastly, flag the black spots along the stretches during the examination. Those are being generally missed. It will be available on the Google map whenever they are doing the audits. Then this is concluding that web-based monitoring is there, geotag photographs are there, prioritization of safety issues are there. On the dashboard I can see which is the most prioritized safety issue. Action taken reports, what is the action has been taken by different stakeholders. And repository, all the audit reports are available on the click of the button. And then road user empowerment, because a lot of these questions have been raised. So Rajmarg mobile app has been launched recently by Honorable Minister. So where it is for the road users, all of you are safety auditors, the potholes are there, safety issues are there, you can click and you can report that. These are the different, you can have any issue. Recently only when I trial this, that these are the safety issues, you can see it's a total observation 19, 14 solved, 5 pending. and then whatever I can see that I accept that observation not. So these kind of aspects are available to all the road users. Thank you very much. Thanks a lot.
Yeah. Now the floor is open for discussions. Audience can pose questions if clarifications if they need. If there are no questions, let me at least ask from my end. Mr. Ravindranath, we have talked about the dosage concentration of the polymer, 3, 4.5, 5.5. Is it possible for a road user engineer to know what is the concentration of the polymer if the sample is given? Second, will it be possible for him to find out whether it's a linear or a branched SBS polymer? Yeah. Mike.
Hello. Yeah. So the first question was, can we find out the concentration of the polymer in
Yes,
bitumen?
you suggested minimum dosage. I want to know whether is it possible for them to know.
So currently it is not possible. There is no to some extent we can know there is polymer, but we cannot accurately know that this is 5% polymer. Accuracy is not there. I can get between 5 to 8%, but that accuracy is not there. And then the difference between the polymer structure also is between linear and radial, it is very difficult to determine, because the chemical composition of linear and radial is exactly the same. Just physically it is different. So FTIR, NMR cannot determine. But linear and high vinyl you can differentiate.
That is true, but by the finally the field engineer will look at IRC SP 53 and he only checks whether it meets the property specifications as per that.
Yes.
He has no say on the type of polymer as well as the concentration.
But we can differentiate between polymer and SBS versus other polymers.
Right, but you say that it is has a profound influence on the performance.
Yes.
So how does the field engineer choose a polymer which will give the performance? He has no say on the concentration. He has no say on the type of polymer. How will he decide, I need this type of polymer of this dosage to give these properties?
Sir, currently IS 15462, they give the liberty of using any type of polymer. But the main criteria is all the properties has to be met.
Yeah, right.
So the users have the liberty to use any polymer.
Yeah, correct. But finally, what will play a role is the cost economics.
Yes.
What dictates in the end is the cost economics.
Yes.
Nobody talks about the life cycle cost and all.
Okay.
Initial cost, because they bidding rates differences in decimals. Okay. So there plays an important role on we know that polymers will give a better performance, but nevertheless the cost plays an important role.
Okay.
Yeah, thank you. Any other question for anybody?
I want to add one thing in this. Actually, right now, whatever the PMBs are coming in the market, all are just the black boxes. Nobody knows that among the 4 type of SBS, which SBS they are using, what is the percentage of that. So I will recommend that in future, just like the medicines, you have the composition. That this is in this, if it is a, say, Ziffy, there, what is the ciprofloxacin, what is the paracetamol in that. Like that in this, it should also be mentioned that what type of SBS they are using. And especially nowadays, sulfur people are using in PMB. But nobody is telling that sulfur is also there. But it is there. If we do the chemical analysis, we find that the sulfur is there. So it should be mentioned on the product that these are the compositions of the PMB, and among them also which type of material they are using, so that the researchers can correlate the performance of these materials with that product.
Yeah.
Otherwise, it will be difficult.
That is true.
Yeah. Thank you.
Thank you. You want to ask a question? Or,
Good morning.
He has got a question. That's a question. Yeah, you can respond to the question.
My question to Ankush, we are using the waste plastic in bitumen long time back in 2013 and onwards. Whether it will be more beneficial to use rubber and waste plastic combined, as you have presented in the paper, some light may be.
Tap it. Yeah.
Hello.
Sir, in our paper, we have used waste rubber along with plastic pyrolysis oil. That is different from the waste plastics that we use in our between modification till date. This is not that solid waste plastic. This is the in a liquid form.
You have converted waste plastic into PPO, oil. That is similar to the waste plastic. You are converting that waste plastic.
Right, right.
Yes, sir, we are converting.
Yeah.
And definitely there is an improvement in all the properties, as you have seen the results of this research results, that all the property, whether it is rutting or even the storage stability, everything has improved.
Yeah.
So that is what we want, that indigenous product using this waste plastic in a different form, rubber in different rubber. It is not tire rubber, but non-tire, but all other rubbers, non-tire. And this modification, composite modification, has improved all the properties.
Yeah.
So that is what has been presented.
Yeah.
Sir, any trial has been done?
Trial sections?
Sir, we have done the mix testing,
No,
but
field performance.
but field trial performance
We will
is
now
not done
No.
till now.
Yeah.
Now we will start some
Yeah.
pilot projects.
I think Mike. Mr. Sudarshan? Yes, yes, yeah. I think, yeah.
The question is regarding road safety audit. Now, there are certain locations which may require permanent mitigation. There may be a permanent improvement that might be required at a black spot. There may be certain locations which only require temporary measures. Where there are permanent measures required, till such time that is taken over, maybe construction of a grade separator, VUP or PUP, still accidents might take place. How it is mitigated and how it is monitored closely, whether temporary measures are efficient till such time a permanent measure is carried out. Is there a mechanism to closely monitor this?
Yes. See, as the DPR TR I have presented also, this has been made mandatory now in the first 3 months. Whenever the audit has been given, then DPR consultant will visit the site and he will analyze the last 3 months data, which will be shortly available on IDAR or EDAR, and then he will suggest exactly what you have said. He will not only suggest the short-term measures, but he will submit the BOQ and cost estimate for also. Till the DPR is under preparation, even that time, that short-term measures will be implemented. It is part of the scope now.
Thank
Sir,
you.
Sir, my question is that this NHI safety app has been integrated with the EDAR or IRED?
It is in process, sir.
Okay. Good morning, everyone. My name is Satyendra. I'm AGM with Rides Limited. My question is to Mr. Popli. Sir, this mobile app is actually real-time based inputs of field data while doing audits, right, sir? So suppose there is one feature also that one can be offline if there is no internet while doing the audits. He can keep on adding data into the mobile app. Then once the connection is there, the data will be automatically synced with the data lake. Now, point is that, sir, one can choose to be offline while doing the audits, right, sir? Now, he can keep on adding data. My question is that whether before uploading the data, means when he chooses to be online, then prior to that, can he do the manipulations in those data?
No, as far as manipulation he cannot do. Once it has been clicked, once photo has been clicked and the observation has been entered, even when it is in his mobile, he cannot change anything. It will be only uploaded. He cannot change it. But still, no, it's okay.
Yes,
but
sir.
still, this aspect I will take care and make it sure that he cannot change it.
The second question is that, sir, when he is offline and just prior to uploading the data, when he comes to online, then I don't think the data will be a real-time basis because
Geotag, it may not be geotag.
Yes,
that is also, we are trying to see how it can be integrated.
Yes, sir. Thank you, sir.
Thank you for the valuable suggestions. I think it will help in the updation of the app. I think, I'm sorry, yeah.
My question is towards Ankush. While you were testing your CRMB binders, in your rheological characterization, you were using 1 mm gap settings for your DSR, especially when you're testing your G-star by Sign Delta and all. You are testing crumb rubber modified binders, so crumb rubber would definitely swell. So how do you justify the gap settings?
So we have used a 2 mm gap for the high temperature characterization, and these details are mentioned in our manuscript in the materials and methodology section.
Okay.
Just to take care of the particulate effect of pre-swelling of rubber particles.
Okay, thank you.
Thank you. I think it's time is 11. I may now request my co-chair to summarize the proceedings of the session.
Chairman sir, Dr. Viragji, Nirmal sir, Secretary General and former DG and Special Secretary, Ankush ji, Mr. Ravindra ji, Popli ji, Yogesh Kumar ji, Parveen ji, and all the colleagues. The two presentation of papers, modification of the bitumen, was very informative and very practical. We should have to go on the modification as our roads are got damaged day by ruttings, patching, and failures with the traffic load. The paper presented by Mr. Parveen sir and Dr. Yogesh, effect of molecular structure of SBS polymer on modified bitumen, and they show that linear SBS and branch SBS, the branch SBS is more useful in polymer modified bitumen, and as per their presentation and research, they showed that these polymer modified bitumen will increase the life of the road as well as the elastic recovery, reduce the ruttings, and increase the life of the pavement. As the dosage of the SBS has 3 to 7%, and shown that as per the dose will increase, the modified bitumen will be better. Similarly, the paper presented by Nirmal sir and Ankush, the composite bitumen modified using the waste plastic pyrolysis oil and the non-tire rubber. I think it is also very important as per the future. We have many wastes which are non-tire rubber, and that can be consumed in the modification of the bitumen, such as our industries, automobile industries and others, which we are not using till now, and as per the paper, we can use in the modification of the bitumen. He also, Mr. Ankush shown that rubber and the PPO can increase the durability of the road, as PPO alone cannot increase the durability and rutting performance. Similarly, the third paper presented by Mr. Sudarshan Popli ji, advisor NHI, the road safety mobile app. I think this is the need of the hour, as in the India, we are facing the road traffic accident, and we have on an average 1.5 lakhs fatal accident on the Indian roads, which is very large in comparison to other countries. Also, it decreased our GDP by 4-5% annually. it is will be very useful, and I think all the states and ministry also should use this mobile app, and we will be more resolve the issue of the road safety as well as avoid the accident. However, accident may be the duty of the engineering as well as the mechanical fault, driver fault, personal fault. But this app is no doubt very good and very useful for the road safety evaluation of the national highway as it is developed by the NHI. We recommend that this app should be used by the all states and ministry also. As the app have all the stage of road safety, DPR, development stage, construction stage, pre-opening stage, and OMA stage. I think very useful and very good app developed by the NHI. Thank you all.
Thank you very much. I think we had 3 wonderful presentations, 2 on modified binders and 1 on road safety audit. I think only 2 days back the council approved the IRC SP 53. I request the researchers who are working on modified binders to relate their experimental results to the field performance so that it will enable us to modify, improve, update the specifications for the modified binders. The app on NHI, one app on revolutionizing road safety audit, perhaps will help us in reducing the fatalities from 1.5 lakhs, even 1% if it decreases, even if one life is saved, it's worth saving that life. I'm sure that with the initiatives taken up by NHAI, we will see a decreasing trend in accidents in the years to come. Let us hope that this app will be a handy tool both to the practicing engineers as well as the public, so that we will try to improve the safety in the country. Thank you, the IRC, for giving me the opportunity to chair the session. I also thank my co-chair and the eminent speakers who shared their research work for the benefit of the society. Thank you very much.
Thank you, sir. Now I request the chairman of session to present a moment to presentators. Sri S.K. Nirmal, sir. Sri Ankush Kumar, sir. Sri Sudarshan K. Poli, sir. Thank you, sir. I request to co-chairman of session to present a moment to presentators. Dr. Yogesh Kumar, sir. Professor Praveen Kumar, sir.